Okay, so I think like the second week or the third week, we looked at using the pawns that are already existing. They were there. I wanted to talk to you about them immediately, so you didn't just get jumped into them and got confused, because there's a simple way to approach them, and there's a super complicated way to approaching. I haven't even digested all the different blueprints that are involved in those with the grabbing and the releasing mechanism. But I kind of want to do it from scratch so we have a way of owning it, and you can see how it has a little bit of freedom to finesse the different settings. Today it's really important that we work in 415. There's going to be a setting I use later on in the demo today that is only included in 415, so it's not as backwards compatible. Always moving forward, like sharks swimming forward. I'm using two controllers today. You can easily just use one controller with one sensor. It's just for whenever you calibrate a new space. You have to use kind of two sometimes. Otherwise, what I'm going to be showing you today is called line casting or ray casting, and it's really important to know where the center of my tracking is for you guys to be able to see the demo really well. So I can start off with nothing if I want to, and then I'm going to do some starter content, so I have some textures built in. And if you check out this computer, it'll be on the D drive, and it'll be called Todd Demo. Under real projects, and then you can break it apart if you want. This project already exists, but I'm like I'm hearing like bugs and stuff, and I realized it's this is like playing. I'm like, I'm going crazy here. Okay. All right. That was another shout out to Unza Malitza right there. It's got to be in the screen recording. All right. So this will be called Todd. Y'all. Cool. And I have starter content, as I said. This is for the desktop console. If we were doing this for Gear VR, this is where we choose doing it as a mobile tablet thing. Okay. So this is doesn't have any pawns. We're gonna do that from scratch. And yeah, and feel free to, if you want to ask some questions, feel free to jump in. Are you still recording? This is recording. That's good. Okay. All right. So I want to create a little. Actually, this will be good. This will be a great way to start. Okay, I'm going to get rid of my. This is the player start, and if I hit start, I will start right there. This is essentially our player 0 that you can default as, and it totally works with VR, as you've probably seen before. But we're going to go ahead and begin with making a custom VR pawn. This idea of a pawn has been talked about now in this class for a little while. It just means that, and it'll even say, like literally say, it's an actor that can be possessed, and that's just the function of changing out between different ones. You can have a bunch of pawns in your scene, and instead of teleporting to a location, you can just switch between different things. And you can also change between different kinds of pawns, where you could be a first-person player pawn and switch to a third person in an experience, and then switch to a VR pawn or whatever. You don't have to be tied to a certain kind of kind. I can also, it's called BP for blueprint underscore PWN, means pawning or pawnage, and I'm going to ignore. I'm going to name it again. BP, great. So what do we need in here? Well, for today, we mainly need to have a camera reference, and we want to bring in the motion controllers. I'm going to show you how to set those up. And then probably maybe like if we're going to walk around, which I'm not really going to be walking around, but we'll add a capsule component too as a reference to a collision. So you just stop messing with me. There we go. So an actor is a thing in the world. Everything inside of this level is considered an actor. These are actors in a world. Everything. This pawn is an actor inside that world, and then we can add components to the actor. That's just a terminology that makes it easy for you to do your blueprints where you're referencing either components of an actor or the actor itself. And so let's add in the camera. Actually, let's add in the capsule component first. So we're gonna have, this is a collision, and that just represents a simple collision. Capsued is not the right word. There we go. And this is represented in centimeters. We can raise it up a little bit to put it on the ground plane, and then we can think about how tall that would be in the real world. Let's go here, and everything's going to be a little bit laggy because I'm screen recording and doing VR and doing USB 3.0, so we're going to go a little slower. Just bear with us so we can do it. So I'm going to make this twice as big. This is all documented inside of the Epic Games Wiki, how to make a motion controller from scratch. I'm just showing you how to do it in a video demo. All right, this will be fine for me. I'm going to add in a camera, just a regular camera, and kind of raise it up a little bit, I think. There you go. And we can adjust this later on. In fact, we can actually just go ahead and throw this in the world and adjust it visually that way as well. Great. So let's just go ahead and put it in the world. Turn it around.
So is this a VR pawn? That camera, it could be like a...
It could be any pawn.
360 cam.
Yeah, totally. 360 camera, you could just use a player start, though. You don't need to have any functionality with that. The whole world's happening around it. The main thing is that we need to start off with this possessed. When we use the VR templates, this is already checked off for us. But since we're not using the template from scratch, we need to make sure that we auto-possess this as player 0. Okay. And that's all I'm doing. And now if I put on the headset, we'll see what the height feels like to me. This is also dependent on what I set my own personal height on in interesting. Oculus is giving me a warning. One second. Let's just go ahead and save this and restart so Oculus is happy. Or let's see, one time. And then I want to make sure I come back to this level. So this one is called Minimal Default, and I go to my project settings so it's easier for me to work, and come back to the auto default to this map. So I always start off with minimal default, and then if I make an executable, it'll deploy as minimal default. That's good. That's a starting. So let me just give it a save and restart. Make sure the VR is working real quick. I'll put this on. Great. Everything's happy there. And now let's restart. All right. There's always something we do in live demos, right? It says I have to go to my general settings in Oculus and allow Unreal. That's a new one. Anyone seen that one before?
Oh yeah, I got it once.
So, what do you think? General settings?
I think it's privacy, maybe general, yeah, I remember it.
Okay.
No, only general.
Okay.
I know, yeah.
Okay. So, hey, now this is documented. This is how you fix it. Great. There we go. So I'm a little bit low. We can see this. You see the frame rate's pretty low because I'm doing the screen recording, but this will be good enough for testing today. So I'm going to raise it up a little bit, and then I'll show you the motion controllers. That'll make me happy.
Change the settings in the Oculus
It,
settings.
how high I'm in the Oculus settings?
Yeah.
So right now I'm at setting height, so I have it like set at 5.3 or something.
Okay.
You can mess around with this. There's people have different preferences. The important thing to know is that if you're doing a Vive or an Oculus, the Oculus is supposed to be based from sitting position, and it says base eye height is 64. That's actually default set for Oculus. If you're doing a Vive, Vive is actually from 0, 0, 0. You'd actually change this to 0 for Vive, otherwise it would be too tall. But let's go and do the motion controllers. So, hopefully this is easy. Let's see. Do you have a motion controller component already? Oh, great, you do. Fantastic. So, I'm going to put the camera underneath the default scene root. And then the motion controller is also, it is attached to the default scene root. This motion controller only has one really setting we're going to do, and that is that we're going to use the right hand on it. And then I also might denote that in the name by like adding on like an R. Great. And then, hey, while we're at it, I got both set up. Let's add another motion controller. Great. And then this one will be by default on the left side. That's great. I'm going to have it parented to the root. Attach. And then we'll be smart about it and call this one R. RL, thank you. Dun, 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 glitch in the matrix. All right. So, but you won't be able to see these. They're invisible. They're just like they're tracking nodes, but they don't have any debug draw that I know of actually. But what we can do is add a component to it. So here is let's give ourselves ridiculous cone hands. And if you have your animated hands, it could be those things. And I know the cones are a little bit big, so let's go ahead and resize it to 0.2 across, uniform scaling. Take a look at it while we're doing it. And let's add another cone. Or let's give another one. Let's add a cube. Fantastic. And also make this one smaller. All right, let's see if this works. Save. Screw that. I'm still on the floor a little bit much. Can't see anything. All right, that's fine. Settings. All right, there I'm seeing it slowly. Okay, it's choppy, but yeah, there's my right hand. And here's my left hand. There we go. So in this world, these are my hands. They do have collision on them. I mean, I can override that here, but yeah, I can go and punch the chair or whatever if I thought that was a fun thing to do. That choppiness is going to be really annoying. Let's see. Let's just raise the camera a little bit. And we can mess around with this a bunch. It's not making any higher, but anyway, cool. This is all fine. So let's start doing something with these controllers besides hypothetically punching chairs. So which could be your whole experience should you want it to be. Let's see. And so you can see that also on these details, I could take any individual component of this blueprint and also edit it here by selecting it and moving things around. Well, save. It should be moved around. There we go. So what I'm going to do is I'm going to get into a thing called, in Unity it's called raycasting, and Unreal it's called line casting. And essentially, we're going to get the world position of this controller, and then we're going to shoot out a laser beam. And we're going to say how long we want the laser beam to be, and then we're going to see all the functionality we have from this very, very powerful tool, this function built into the blueprints for pawns. And what it's going to do is going to be able to identify the actors in your scene, and then we can do things like find out their location and a lot of different properties. So I'm going to take the right motion controller and go into my event graph and just grab a reference to it And I just want to know, what is my world position on this? Where does it live in the world? Where's the origin of this? So I'm going to get my world location. And that is a yellow value. Yellow is a vector. That's a 3 float. I could split that apart to get more of an idea of like X, Y, and Z. But for me, I'm going to be doing some vector math, not in my head. I'm going to let Unreal do vector math for me. How about we say it that way? So I'll recombine that. So great. And we're going to do what's called a line trace. So I can say line trace by channel. And look at all these goodies we have to play with.
Is this like ray casting?
Yes, this is ray casting. And we want to, for this example, we're going to be doing it in every frame. So we're going to do it off the event tick. Cool? And so I know where the start is. But how do I know where the end is? I need to be able to see the orientation of where I'm at, because the position doesn't have orientation, just my location doesn't show me where I'm pointing. So I want to be able to know my orientation and find out where this is. This is called my forward vector. And this is line tracing as I do, like if you have a Gear VR and you don't have any controllers at all, you just gaze tracking. That's gaze tracking is forward vector. So
that would be attached to the camera?
that would be attached to the camera, not the motion controller. Exactly, that's a very important point. So we're going to get orientation first. Or we get rotation. Get world. Rotation. Okay, and that is this value is now a purple. Purple just means a rotation vector. You can split that apart and see that that's a roll, pitch, yaw. So we're going to get the world rotation. I'm going to get my forward vector, which way I'm facing. Great. And I want to think about how far I want to sample. I don't want to just shoot off a laser into infinity. I want to control that so I'm not doing as much processing. I'm only processing the things around me. So let's go ahead, and if we multiply this by a float, and then we say let's just do 1500 centimeters. Cool. And then we're going to add it to this location. So we're going to start at an origin, we're going to face a direction, and we're going to start at an endpoint. So let's add it to our original, and this creates a ray. So this is just a vector plus a vector. Fantastic. And this goes into end. And then we want to be able to see the debug draw. We want this to be visible to us. So let's go ahead and draw on every frame where that laser is. So let's go ahead and take a look and see if this works. And I'll save just because everything's running a little choppy. I'll make sure that this is in case we crash. All right. So all right. So can you guys see that red box? All right, so that red box means that that's the hit point, right? So I'm hitting the collisions on this chair, hitting the collisions on that table. This is the raycast coming from me. Oh, I hit my floor right here. I'm going to get rid of this silly looking cone.
From your motion controller.
Yeah, coming from my motion controller.
And it draws that box automatically because you checked the box of show me.
Yeah, it said show for one frame. Now I can say show me everything I hit over the course of the duration of a certain time, or just make it always show persistently for the whole time I'm playing. And then I can make laser art. Yay, so now there's all these. And it looks like a ballistics report at a crime scene. Fantastic. Cool. This is an extremely powerful tool. It's a lot of fun to play with, and let's get some data from it. So we want to break out the what we're hitting at. It's called breaking the results, and see all the different data we can get. So break, hit, results. There you go, out of the hit is what I should be doing. Cool. And look at all these things we could do. We can find out how long it's been looking at something. We can see the location of that thing. We can see the angle of the normals on it. We can find out the name of that object or the component of the actor, bone names. Like, this is a lot of stuff we can get from this, and it's all computing real time. It's super cool. So the first thing I want to do is just let's find out the names of these things. So I am going to just print the string from the actor. And that is totally not what I wanted. Let's print the string here first. Here we go. And then the pink there is a string value. It would just say hello. And this will just automatically cast it from an actor component to a string. There we go, automatic conversion to a display name. All right, let's take a look. And we should be saying things like chair, statue, table. And there we have, you see chair, floor. It's telling me the name of these things. You see there at the top. That's super cool. If you look very top left, it'll be printing string. Very top left. See that? It would print a longer string. My frame rate's so low, it's only doing every frame. I'm only getting like 5 frames per second. If I was doing this without screen recording, it would be all the way down because I would be getting 90 frames per second, and the execution pin would be firing more often. I'm trying to do 2 things at once. Give you guys recordings. All right. So, well, cool. That's awesome. We can now get the names of these things, and so we could think of different things we want to do with that. You can say, I don't know. Anyone can think of anything you could do with knowing what name of the thing you're pointing at?
Lots of stuff.
Yeah, lots of stuff. Yeah, you can then from that name you can find out. You can change it. You can push it around. You can manipulate it any way you can kind of think of. We can also not be as precise and not worry about the thing itself. And what we're going to do now is kind of create like a gravity gun. So instead of actually doing something specifically to an object, I want to do something to a specific location. So instead of the name, we're going to print string of the location. And let's just prove this works real quick. So now we're going to get X, Y, and Z location of the things I'm looking at. All right, so the floor is the ground, and the chair is over there. There we go, and we're getting those values X, Y, and Z. There we go. I'm also going to just do the 1 frame, see if I can. This is less intensive. Okay, great. And I want to now. I'm just going to try push them away. I want to actually what's called apply radial damage. So this is like creating an explosion, kind of. Apply radial damage right there. Cool. Look at all these things I get to do with it too. I'm assuming that I want to get the origin of this damage is going to be from my location. Damage, I don't know. I always like to do as much damage as possible. So just a bunch damage. I don't know what unit damage would possibly be in. Centimeters per second, who knows? And then it needs to have kind of an origin, needs to have some sort of area that the damage is coming from. And I think a good value would just be like 250 or something. That might be too big. We can always adjust it later. And so we need to make sure the objects in our world are physics objects, that they have collisions and that they can be moved by things like gravity and stuff. So I'm going to try to shoot this little statue, and let's take a look at it. I'm going to squeeze this up. All right, so the physics statue, that's materials, blah, blah, blah. And so we're going to say simulate physics. And just because I want to, I'm going to override how much it says it weighs, 7 kilograms. I'm just going to say 1 just because I want it to go flying. And let's do the same thing for the table. Simulate physics and make it just 1. Chair, the same. And the other chair, the same. All right, saving. Let's see if we can get this to work. Oh, let me make sure that the pin is hooked up. So I don't want this to happen to every frame. That's going to be kind of crazy. I want to actually start using this controller for more than just pointing at things. And it has lots of buttons, and I'm going to use the trigger button, okay? We'll just see that if I do context sensitive and I say trigger, we have motion controller right trigger. So this will be the same for both Oculus and for the Vive. This is just motion controller right trigger. You can see right here, this is something we've been talking about, the fact that the Oculus controllers have capacitive touch, and then that's also triggering off of touching and untouching the capacitive touch features. But we're just going to be using it as a regular trigger, and we want that when we press it, we're going to send off Great. All right, let's see if this works. So I'm pointing at the chair. There we go. Everything's slow motion. No. Oh my. Oh no. Oh, it went flying first. Yeah, it was the first casualty of this experiment. All right, so the things I might want to adjust, maybe we don't need 1 million damage. 100,000 could be sufficient. What unit? I don't know, centimeters per light sockets squared, I have no idea. And
That little server symbol in the corner of the
this right here?
Yeah.
I think it'll even tell me. I don't even really know. It says it's server only. So if we did it on 2 different screens, which we haven't really got into because we're not doing projection in this class, you'd have to actually replicate it somehow.
Okay.
It doesn't get replicated automatically, but that's kind of beyond the scope of what we're doing. And then I thought that the radius was too much. We hit too many things at once, and I want to be more localized. So that's great. I mean, maybe I might be a pretty sophisticated level designer, and I might want to think now that I can let's make some barricades so they can't run away so quickly. They got it off pretty easy. All right, so just making art, and let's drag it out. Fantastic, I'm over at it. Let's drag out the floor, move it over, and then for fun, let's add in. So if I hit Alt, it duplicates it when I drag it. All right, so we're making a little corral, a little pin they can't escape from. And then I'm going to add in, just for fun, some more objects, like spheres. Sound like fun. And then I'm just going to make sure that they are simulating physics, and that I'm going to make it a little easier to make sure that they go flying away. So I have one of those, and then now I can Alt drag and make a few of these also to mess around with. And then now basically we can play pool. We got little corner pockets and everything. Maybe I'll just make this a little bigger so it just goes behind us. This is where I wish I was more like Bob Ross, making happy little pool balls. A happy little pool table. Happy little pool table. Okay, that's great. So, I mean, we know this is going to work. Let's just go ahead and give it a shot anyway. Hello. Hello. So where's our? There we go. There we go. Flying away, less forcefully. You reduce the amount of damage. Guys, this is way more compelling when the frame rate's up. I have to tell you. I have to tell you for sure. I have to tell you for sure. But yeah, this is kind of fun. But what do you think? What are some of the things we're missing? I don't know. It needs to have at least a sound, right? Well, we don't know if you guys will be able to hear that. Let me just do this just in case. So let's just add sound. This is just an example of how to like make blueprints the way you want them. So this is like a kind of a line of things that happens when we apply radial damage. Let's also go ahead and play a sound. Let's look at sounds really quickly though. Let's see, what sounds do I get from the starter pack. I'm going to filter by sounds. Sound wave. Cool. And we have explosions. Let's see if this works. It's in my headphones. Let's see. Sure, whatever you want. Oh, come on. Well, yeah, well, that's okay. So we're not going to be able to hear explosions, so let's go ahead and draw explosions, okay? So we're going to make a new kind of material. I still wanted to show you some stuff when it comes to sounds, but whatever. All right, so new material. And this material is going to be called decal. A decal is basically like a sticker that if you don't want to do a material to a whole object, you just want to add a sticker, this is your guy. And I'm going to open it up. And let's find a texture that we want to use. I'm going to filter by textures and look at all the textures in here. Whoa, there's lots of textures. Let's find something awesome or decent. My standards are not really that high. Let's just use this checker. I don't know what this checker is going to do, but we'll find out. So I went ahead and selected it in the content browser, and then if I go over here and I type in T and click, it brings in a texture sample, and that thing's already loaded here on the left side. So that's just a little shortcut for bringing in things from the content browser sooner. But before we connect it, let's look at our decal. The decal has the material preferences. We have to go to this material domain. This is no longer a surface material. This is what's called a deferred decal. And then it's telling me that it needs to be translucent. So I'm going to make it translucent. Great, and that error went away. And then under the decal blend mode, which is a new kind of thing we looked at, we have wonderful words like stain and volumetric distance function, which is experimental. Let's do stain. No, let's keep it normal for right now so we can see it better. Let's connect it. Let's not do normal then. That's a normal map. Let's go to translucent after all. So I'm going to give it a base color. And we really don't have any opacity data here. So this might be just fine. Let's see what this does. I did nothing. Let's see what this does. That's fine. All right, so what we want to do is we want to be able to see where we're hitting. We're going to apply this decal at that origin, the location of collision. All right, so let's go ahead and save and close. And when I apply radial damage, or actually we're going to say is we're going to do two things off the motion controller trigger. We're going to make a sequence, so these two things happen on the same frame, but in this order. We're going to first, if I hold down control, I can drag this pen down to here. There we go. So first, I'm going to spawn a decal at location. Cool. Could it really be this easy? All right. So let's find our decal material. We called it M_decal. Cool. I know that I want to have it some size. I don't want to be 0. So let's just start off with 10. I do believe this is in centimeters. Location, well, we're getting that location from right here. It's wherever we collide. And then I can't really think of a way I would want to do the rotation, so I'm going to leave the rotation as normal. And then the one thing I see is lifespan. I'm assuming I have to give it a lifespan so that it stays around. It's one of those things probably where it starts accumulating and then they start peeling off. You know, you don't want to have, like you see video games where people like shoot and there's like a bullet hole in a window or there's a blood splatter. It usually disappears after a little while. So let's say 100 seconds. All right, let's give it a shot before we go any further with this code. All right. All right, let's see if it works. I'm not seeing it just yet. Let's see if it's on the wall. Oh, there we go. See that? Not happening on the walls, not happening on the ball. It happened on the chair a little bit. But the floor is definitely working. I think it might be tied into the rotation. Let's just rotate real quick and see if that changes. Oh, it's at negative 90. Let's make it 0 by default. We could probably also not make them go flying away, and that might be easier to see as well. Let's take off the damage for right now. All right. Try again. Floor we've established works. Ball. Oh, it's actually on there. It's just really, really light. So let's make it a little bit darker. And decal settings is not really what we're getting into too much today, but we can definitely make sure that you guys can see it before we move on. So let's try stain. Stain, nice, and also put the color in the emissive. Ahead of myself. There we go. You see on the wall? Okay. So now we're adding it to things. It's just not as bright as we want it. But anyway, that's cool. So we're not really having to be precise with what we're hitting, just if it hits anything. Okay, emissive color. And great. Okay, so, but I don't want to just like every time I click it, because that seems to be frustrating because I have to hit a frame rate at the same time I'm hitting a trigger, and it's not really going off as much as I'm pulling the trigger. So what we're going to do is we're going to look at some flow control. And instead of just when I hit the trigger, we're going to actually say when I hit the trigger, it's going to actually open up a gate. So there's a flow control object. This is just like branching as flow control and flip-flopping. This is a gate.
Where's the gate?
It is this. So when I hit the trigger now, I'm going to say that data can enter, and then, or when actually I'm going to say when I hit the controller, the door will open on the gate, just like another gate in the real world. And then when I release the trigger, we're going to close the gate. And then we're going to continually send data in from the event tick and to enter. So this is starting off closed, as it says at the bottom. That Boolean means that it's closed. and then when I hit the trigger, it'll open the gate, and then every frame it'll just be firing out. So this is like the metaphor for spray painting. And then when I let go of it, then it'll close that gate, and that event tick won't be able to go through and execute the following piece, which is the spawning the decal. Let's take off this. So now when I open it up, it should just be painting. So now this is a data visualization of my low frame rate. Yay! And then we can have it combined with the idea of making them go flying away, so we can say, you know, the gate is only for spawning the decal, but also then just when I hit the trigger, you can still send things flying away, which I'm sure we all understand what that would look like. So I'm playing pool and also spray painting at the same time, multitasking in VR. Great. And truly much better when you're not doing a screen recording. All right, so that's my right hand. What's our left hand going to do? So and with our left hand, we're going to actually just be drawing in 3D like tilt brush. So I'm going to show you guys particle systems for the first time. And we'll make a simple particle system that has no acceleration or velocity. And then we'll be able to spray paint and draw at 5 frames per second. It'll be technology. It's amazing. So we're going to make a new material for our particle system. And we're going to, this is going to be a ribbon trail, which is a certain kind of particle system. And if you've seen some of the tutorials we've done before, we've done this. I've used this one before. It's a little bit lower CPU intensive than doing some of the other ones. And I think that's what we need to go for. So there's one thing to make sure that probably doesn't make too much sense, but I just let you know that it is the case. We need to get UVs of like a particle system, and it's just like we need to know that this always starts off with particle color, and then we need to multiply whatever color we're sending in and what kind of opacity data we're sending in by this particle color so they can work in the particle system. It's just like how do we say that the material was a deferred decal? This one we're saying it's a particle material, just so it can allocate all the different things it needs for rendering it. And so what we're going to do is instead of using a PNG to start off with, we're going to kind of create a texture with math. And first I'm going to start off with UVs. So I'm going to hold down U and V. And we might have talked about this before. U and V is how we're talking about up and down and left and right in 3D space. As my orientation changes around, Y and Z and X are always the same way. But my U and V, we need to talk about that reference. It's kind of like how you talk about different things in boating terms with like stem and stern and all this kind of stuff. You have different references based off of the differentiation between them and the other coordinate systems that you have. And what it is a green gradient and a red gradient overlapping each other. So I just want to use one of these gradients, and I'm going to say, I'm going to mask, that's going to be a multiply. I'll save that for a second. I'm going to mask a component out. And this is used for converting 3vex to 2vex and all that kind of stuff. You see on the left side for details. I can add in a blue channel and an alpha channel, or I can remove them all. And I think I'm going to remove the green channel, and that gives me a left-right gradient. I'm going to actually get rid of the other channel, and this is a top-down gradient. All right, so we're getting a gradient from math, no PNG involved. I'm going to multiply it by 0.5 to lighten it a little bit because I'm about to do some more math afterwards. So multiplying something by 1 is just going to equal itself, but multiplying something by less than 1 will make it a less bright color. And then I want to multiply this also by a sine wave. So that's actually some math we have in here. And now it actually starts at black and it ends at black. We've kind of created a gradient here with that. One second. Lost my internet over here. And then just to make this more apparent, we're gonna multiply it by a power of 4 to make it a little bit more dark at the top and bottom. So I think that might be P. No, it's Panner. We haven't gotten to Panner yet. Let's see. POW. Square rooting essentially. There you go. Now you see that bowing much nicer there. Cool. So as I said before, for me to get in color data and alpha data, I need to multiply it by this particle color thing. So M and clicking gives me the multiply node, and I just want to multiply the color. For my base color, and I also want to use the alpha here, and then this by multiplying the black level, the grayscale level, especially the blacks, by the alpha, will then convert those to alphas, and then this will go into a material that is going to be translucent. And if we look at this, there it is. So we just created a ribbon, and then we're just going to be drawing this ribbon on, and they're going to be emitting it, and it's going to create a trail. Okay? And this is as lightweight as we could possibly make it just by using math, not having to worry about bringing in PNG that would then draw 2,000 times. So we're going to create a new particle system from scratch, and this one is called M Ribbon Trail, and we're just going to go through it. This is, and it's not M, it's P for particle system. All right, so this is called Cascade. It could do a whole lot of things. It's a lot of functionality, and it kind of starts off with just an emitter. And what this is doing is it's sending things with a velocity up, and also a slight velocity to left and right. And that's giving us that differentiation between the emission of, these are just like place filler textures. All right, and if we actually look at that initial velocity, if I hold down Shift and hitting these triangles, it'll troll down everything underneath it at once, so that we see that there's a max and min, because the particle system is trying to make it look very organic, so everything is within a range. It's, you can also make things be exact constants if you want something to always be the exact thing, but that's just by default. They want you to use a range, and we can see that this is going between 1, I can actually do this to make it a little bit less confusing. So we have on the left and right, it's going between 10 and negative 10 in velocity. On the y, it's going 10 and negative 10. And then the velocity on z, which is up and down, it's going 50 and 100. So it's going, there's a range of how fast it's going up, which is why some of them are making it further and some are making it less. All right. So let's start at the top, and kind of each of these little squares is some data that we can either delete or change, and then we can also add some more data should we need to. Essentially, I'm going to click here, and actually that would be adding one. I'm going to click here, and I'm going to say type data. And as I told you before, this is ribbon data, so it'll know, it'll start rendering different as soon as I hit the ribbon data. So there's a different kind of particle system. It's going to be ribbon data. It wants to be seamless. It wants to draw this, instead of being like individual different sparks, it's going to be a line. So there we go. We've already changed that. The next one's required. The required is whatever material we're using. So let's bring in ribbon. Let's zoom to height. So we have a ribbon. And now let's just watch and see how it changes. You might have to save it. And there we have a very faint ribbon. Cool. Lifetime, let's make it last a lot longer. In fact, we can make it last a really long time. So instead of doing a float uniform, I'm going to do a float constant. And this just gives me one value, and they're all going to last like, 1,000 seconds. So now we can watch it emit, right? There we go. We have this trail coming up. That's cool. And what are the other settings we want? So we're just moving down. Initial size. Also, I don't think we need a range. It's giving it, 25 to 25. Let's just make this a constant too, so we're not confusing the matter. So you're always going to be 25 big. This might have done them that much, but as when we get over to velocity, you'll see the difference. So the initial velocity, let's get rid of that left and right. So I'm just going to say 0 and 0, 0 and 0. There we go. So this is our ribbon trail, and there is still some variation there because it has different z velocities, the velocity that it's going up. But we're not going to be actually having an emission. We're going to be drawing it on. And so, as I said before, drawing in tilt brush is actually a particle system with neither velocity or acceleration. So this might look boring now, but this emptiness, this void of anything, is our ribbon trail right now. So it involves having faith in me. So we're going to go into the pawn, and on my left controller, actually I'm going to, with this selected on my content browser, and I'm going to save everything right now. All right, I'm going to go into the pawn, and I'm not even going to do anything with this for right now. We're just going to go and add in a particle system, and it's context sensitive. It knows that ribbon trail selected on my content browser. It's going to bring it in, and it's parented to my left controller. And the one thing I want to do is I want to take off activation. So it's not activated. That's how you turn off and on particle systems, so they're not actually emitting. All right, so not activating. And then I'm going to bring a reference to my other trigger. I have to spell it correctly. And this was be my left trigger. Bring in a reference to my particle trail, or as I said, train, ribbon train. Let's see. And then we want to, then when it's pressed, activate. And when it's released, we want to deactivate. So activate, deactivate. Great. And let's see if it does the thing. So now I'm drawing a ribbon trail at 5 frames per second. Cool. And it'll just stay there for a while because I gave it a life of like 1,000 seconds. I think it's a little bit big. So I'm just going to make it a little more graceful and dainty and just say initial size, make it 10. And then it was a little choppy. Set spawn rate. I'm going to give it a significant jump up and say 100. Save. Maybe I have to hit the button before I do that. And this looks a little bit better. But yeah, the frame rate is definitely limiting. So now, this is my tilt brush. And there you see it kind of emitting and going away. Lifetime. There we go. Drawing, it just seems to have rendering issues right now, but that's to be expected. So, but what's cool about this, and that you don't really have in tilt brush, is that you can add acceleration and velocity. So if I go back to my initial velocity, I can change it to something a little small, like 5 to 10 up. And you see I'm creating like a little candle flame right there. And this is kind of fun, so that as you draw it, it all floats up out of the way. So we now have more functionality. So drawing it, and it'll all start floating up. like smoke. Draw again. And it floats away. Kind of the wrong direction too, but whatever. So, and trust me, this is a lot more fluid and a lot more fun without the rendering bottleneck. Cool. So, we have this kind of stuff. That's great. We can draw with the motion controllers, and I just want to do a couple of things with the level sequencer so that you guys can do some more stuff on timelines. So this is kind of a shift in direction, but you know that Unreal has really made striven to put a place themselves within the realm of like real-time rendering and making cinematics and that kind of stuff. And so they have a cinematic tool that's called a level sequencer, and it's underneath the cinematics button. And I'm going to add a level sequencer right now. And this is like a nonlinear editor for your Unreal experience. We're just going to call this, new level sequencer is completely fine with me. All right, and you see this? Now we have a timeline for Unreal that things can be triggered and animations can be blended and cameras can be moved. And then it has a great curve editor and all sorts of stuff for finessing our tools. So I'm going to kind of dock it down here, and I'm going to take this pawn of ours, this little pawn of mine. Alright, and I'm just going to drag it in. And I want to add a track to it. There's a bunch of things I could do to it, but I just wanted to add in something for transform. I want to be able to change its location. So click here, and let's add in a transform track. And we could keyframe, I don't know if you saw, like all the components are here, so we can keyframe activation for the particle system here. We can keyframe anything that would be relevant to those components in this track as well. But we're doing the things for the actual actor itself. So we're going to edit the transform, and so quite simply, I'm going to take a location and move it to the right, and keyframe the Y, and then move it to my playhead up, and move it to the left, and then add a keyframe. So now this is the animation. Right, this is how you do Rails. Should we want to make this a little bit more interesting, you can start with the start and end point, but you can also move to the middle, move your playhead to the middle, just like After Effects Premiere, add in a keyframe, and then I can kind of move it like this, and on a different let's see, move it like that, and then we have a keyframe there. I see. And there we go. So now we're like creating a curve. Great. So now I've created a kind of a track. There we go. Cool. And you can see that we can also select these keyframes and change the curves by highlighting them and right-clicking. And then we can like make this linear, because maybe we had talked about not wanting to have acceleration, deceleration, and pawn movements. Always having it consistent. That would actually be a linear keyframe coming out of 0. But I'll let you guys, if you try to do things on Rails, I'll let you make that decision whether you like it or not. If you're going at a slow enough speed, it might not be an issue. All right. So let's close that, and let's give it a shot and see if it works. Sometimes it's a little buggy if your playhead is on the sequencer, so I like to close it when I'm not editing at all. So let's see if it works. And what was that? Oh, it's gonna be the frame rate's gonna get me sick before anything else. It's not moving just yet. So Let's see how we did this before. Oh, it's because I've actually been told the sequence when to play. We could just say autoplay, but this could be something that we do in blueprints too, that when you reach a certain point, then you start animating forward or something like that. So we'll just automatically play. And we can make it loop. No, that might be sick. Let's just do it once. There, now I'm on rails. Yay! I'm animating. That's fantastic.
So if you were to record that sequence and export it, would it only show where you were looking at, or would it show everything in the 360? Like
I don't think this would do a 360 export. So now that you have this level sequencer, you can actually, with regular camera work, you can actually render this to a video. This would be how you do a video preview, and it doesn't have to do it in real time. You can do it asynchronously. So like you could do big screens from Unreal, and it would just render it like, it would take like 30 seconds to render a frame instead of doing it in real time because of the frame, the size is so big. But what's great about it is still like hundreds and hundreds of times faster than doing it from a 3D engine or like Cinema 4D or from like After Effects. I'm going to make this timeline a little bit bigger, and I'm going to show you how to do custom events, and then this will be good for a demo. So I can just select these and move them over, right? Just move them around, no problem. And what I'm going to do is I'm going to add in a different kind of track. There's a whole bunch of tracks we can add in. You can add in a fade track, which literally all it does is fade in and fade out. So you can start off at black and go in and animate this on a curve. You can actually add in, and then you can also select all your actors for your sequence. So I can bring in anything like the chair if I wanted to move it, and then it would be inside of my level sequencer. I'm going to add an event track. So my event track will, I'm just going to add a keyframe here in the center. And then if I right click on the event, I can see properties, and there is an event name. This will be context sensitive, so I'll keep it always lowercase. It makes it easier for me, and I'm doing this as event 1. Cool. Actually, let me need this anymore. Event 1. And then if I go into my level blueprint and I type in custom event, and I make this a, say, 1, really small. There you go. Custom event. This is something that fires off and does something. I think everyone loves particles. So let's go to the content browser, and we'll add in another particle system into our world. Let's say explosion. Boom. And we're going to say that it's not activated to begin with. Not activated. Then with it referenced here, with it selected, we can bring in a reference to it and say, hey, when this event 1 happens, can you activate, please? Activate the particle system. And it's just a one-shot thing, so we can continually activate it and it'll continue to explode. It's not like a ribbon trail where it's continuous. All right. Cool. So let's just see if that works. We'll just play it in the editor. But you saw it worked, right? There. So this could be all sorts of things. You can, we can have a lot of these things be interactive, procedural. So like if you're moving forward, we can go across triggers and as we overlap those and make overlap events, we can do it that way. Or if we have everything on a timeline, then we just have everything happen at a precise time, and then you're actually telling stories and doing things like you would be doing in Final Cut or Premiere on a timeline. And there's all sorts of different snapping features, so that it could snap to frame rate or seconds, or your time code, so that you can match up with your sound and video files that you're using. The one other component that I want to add in, because I think it's super important and we might not have really gotten into it, is dealing with how do you blend character animations. So I've downloaded a couple of files. I'll go ahead and import. And let's make a little folder for character. All right. And import from my downloads the Magic Spell Pack. I have this female base mesh. I'm going to bring in just the skeleton and the mesh, but I'm not going to bring in any of the animations for right now. This is just paranoia on my part. I always like to just do this first to make sure everything's working before I bring in a whole host of animations that have to be processed. So that seems to work. Great. And now I'll bring in the animations and apply them to that skeletal mesh. I have to hit maybe the button. There we go. So now I'll bring in everything else. And we're going to bring that in on the skeleton for the female base animation, and it'll just be the exported time will be fine. And hopefully this just all works. So we really don't need to go into Persona, like the skeletal mesh animator, because we've kind of seen how all these animations look in their default form. But what we're going to do is we're going to bring in the skeletal mesh by itself first into the level. Put it right here, hanging out. Cool. And now let's add it to that sequencer. Just drag it over. Alright, and you see right here, I can move the transform, I can make it move around. So some of these animations where we were walking in place, we can now time them and so they're moving at a certain distance. And we can also bring in the animation track. So let's bring in animation. Actually, I'm going to move my playhead back to the beginning so that it'll start at the beginning. Bring in the animation. And then here's everything that we have available to us. So it could be just being standing idle. That's fantastic. I didn't seem to do it. Yeah, it is from the beginning. So there's standing idle. So this is a magic pack. So this is how you idly stand by when doing magic. Right? And then I can. There's a wait thing that we're going to do in 1 second. I'm going to add another animation right around here. And then I'm going to switch to a doesn't matter to me, this first one. All right. So if we scrub forward, let's bring it up so we can see it. So we scrub forward. Let's just see how smooth this is. Well, this is actually designed to work right, so I'm going to kind of make it not work right. So as you see, the one on the bottom is actually the one that's taking over. It's kind of the counterintuitive from doing it from like a video editor where it's always the ones on top that are stacked that are doing what you want it to work. So to get this weight transition smoother, we can keyframe animate the weight of the idle. So it would be starting at 1. Starting at 1, I said. There we go. And then when we get to here, oh, the other way around. On this guy, we're just going to end at 1 and just start at 0. And now we're blending between animations. That was the exact opposite of what I wanted to do. That's good. That way we see it works. There we go. So from 0 and keyframe, we saw it popping. Now we're going to see how it's going to be smoother to 1. And to a, let's see, I think I was right before, and then it should be above. Okay, so we'll just fix it and make it right. So we want this to be working right now, so we want it to be at a 1. And I think I need to keyframe the one on top. Let's add another one. It's closed. Let's bring in the animation. Magic attack. Boom. So does it pop? Boom, boom. All right, so yeah, it's popping from one to the other. let's just figure out. There we go. So I really think it does want to be 1. And obviously this is the one part of this demo that I didn't rehearse before I started today. But this is a new feature only in 4.15, and you can see you can keyframe the level of influence that they have and make things crossfade. We can also probably make them go from 0 to 1 at the same kind of time, but inversely. So this is kind of how we can blend all the different animations that we have from our characters. And just in case we do more motion capture, you just want to use what we have in we download from Mixamo. Besides that, was there anything else that I promised I was going to do today? We could really quickly talk about SVN. So let's say I'm done with. Actually, what we could do is talk about using different levels. So this is a level, all right, and then this one's called minimal default, and I'm going to create a new level, and we're just going to use like this guy that has some information. All right, this level we're going to go ahead and make some changes. If I just bring this over, now when I save it, will make me give it a new name. Great, and new map is really makes me happy. That's fine. So now let's create a new level. So let's say we have 2 people working on both these levels side by side. When I go to new level and I do maybe a blank one, completely dark, I can go to the window for levels. Boink. And the persistent level is the level that is always there. It's persistent. It always exists. But you can have different sub-levels that you can turn off and on. And I can actually just say, yeah, let's go ahead and add some existing levels into here. So let's say you're working separately, but you want to start adding things in. So we have a new map we can add in. Cool. Let's add in one more for the minimal default that we had. Maps. Open. There we go. So let's take a look at it. They're both visible, and look, we have these 2 maps that are overlapping each other now. These are both things I did. Right? They're both visible. They're both there. I could turn off one. There we go. I could turn off the other. There we go. They're all happening on top of each other. And what I can do is I can, if I'm working in version control, or if I'm working in different projects, I can actually have one person working in one sub-level doing things, another person working in another sub-level, and they won't conflict because they're actually considered separate levels. And then to keep the persistent level with no one in it, there won't be problems with version control. So then over here, the view options, I can do things like, hey, only show the items that are in the current level. My current level being the one right here, the minimal default. So with that selected, I can just select all and move them over, and I've just taken the whole level, put it over there. And then I'm going to go to the new map. I said I'm going to go to new map. There we go. And only show in the current level. That's great. Maybe get rid of this wall. Yeah, sure, why not? And select all. And I can move everything over. And so yeah, this is how you can align all these different levels to be kind of side by side with each other. And then on blueprints we can say open and close streaming level as we walk down a hallway or something like that. This is for big worlds. You would do this so you can optimize and turn things off and on, so you're not rendering everything all at once. But this is also a way of separating out a project into different sections to work on simultaneously. And then we'll get into, I'll do Tortoise SVN, I guess, next week, so we can see actually version control. I could do it on the office hours if you want to do it later on. But it's in my YouTube tutorials on version control, usually in one of the last weeks. I don't know, that was a solid hour-and-a-half demo, so I think we'll do a break. We'll come back, and then we'll just sit in groups, and I'll walk around, see where you guys are at, and see if I can help out with anything. And I feel this might be productive. And then next week we'll maybe stand up in front of here again and show where we've been now that we'll have had 2 weeks to make progress, and then you guys might be further on to be able to show renderings, show the assets you're using, and we can see how you're making it along, making your progress. This project will live on this laptop if you want it, and you can check it out. And this new level is called Untitled. All right, so let's take a break and we'll come back in like just 10 minutes or something like that.